Okay, now today we are going through 3.4. Now again, yes, this section is just a review from your Algebra 2. And the calculating is not too hard. Now, we want to review some formulas first. The formula, we have 4 formulas here. So, last time we talking about the one-to-one property. And today we also want to talk about another property, inverse property. Now, same thing, we are not going to prove or explain the formula here. If you have any question, I will explain more detail in the class. But since this is just a review, we want to focus on how to use the formula to do our calculation. Okay, so if you have same base, you may simply cancel out the base. Then you have x equals to y. Then you are done. If you have same log base a, you may cancel out the same log base a. So what do you have left? X equals to y. So let me rewrite here. You cancel out with log a. Okay, and then log. Now, if log a and the log a on different side of the equal sign, then you simply cancel out. But if log a and the a in the same side, then they are inverse function, right? Exponential function a to the x equals to y, and then log a. If you input the y and output is x, but when we exchange x and y, then this is the inverse function. So this inverse function, they cancel out each other. Same thing here. This function and this function are inverse functions, so they may cancel out each other. So this is number 1. Number 2. Now the rest of the question, we have 2 different methods. When we want to solve for equation, like this, you have 2 different methods. So you have method 1 and the method 2. Now, all the work I show here always use method 1. I say it's by definition. Method 1 by definition. Now, my definition is the input x plus 1 always equal to the base to the exponent. So input is x plus 1 and the base is 5 here. And the exponent, this is exponent. Okay. The other method, let me show you just one time. It's the right method and it's very good method. Why I didn't use it here? Because I would like you to be very familiar with go by definition. It's very useful, this concept. Now for the calculating wise, you may use either method, no problem. Now let me copy down this question here, okay? And then the second method is when you see base 5, then you pretend this whole thing is one exponent. Remember, the output for the logarithmic function means is the exponent. Now this exponent need a base. So what's the base? 5. Okay. So by this way, then you may so by this way you may cancel out the inverse function. Now keep going. So keep going. You have x plus y equals to 5 to the 5th degree. So x plus 1 will be, you can calculate. I calculate here is 3125, and then take away 1 on both sides, 3124. So that's how you solve for x equal to 3124 by using second method. Now, which one is better? They're both good. And it depends on question. Probably one is easier, one is a little hard. Depends on the question. Now, again, this question, you may directly solve for x. But actually, they already asked you, how about if our answer is this, this? Your job for this question, the rest of question, they won't give you answer, okay? You don't need to, the question is not that easy, just ask you to check the answer. If they provide the answer, ask you to see if yes or no, then basically you simply just plug in this number to the x. You plug in this number to the x. So number 2 basically is you need to learn how to check your answer. Check your answer. Check your answer is very, very important in this section. So I would like to explain why this is very important. Even though this question, I may hand calculate my own answer without checking my answer, right? Now, why we need to check our answer? Because there's a very important concept is the input. Okay, because our input need to be positive, or in other words, greater or equal, greater than 0, not equal, okay? Cannot be 0. Why is that? If you have question, I will explain in the class. Today we want to focus on how to do the calculation. Now, what's the input here? Our input here is x plus 1. In other words, x plus 1 need to be positive. So those answer from part A, part B, part C, if you plus 1, yes, they're still positive. So they are fine. As long as you plug in, you satisfy the equal sign, then that's okay. So how you check your answer? Number 1, your input need to be positive. And number 2, yes, you want to solve for the equation, so need to satisfy the equal sign here. So let's go to number 3. So number 3, you can use either method. I just go by the definition. Go by definition. Denominator means negative degree. So you have negative degree because this 5 is on the denominator. And you try to change the base to 5. Now, when you have same base, you simply cancel out the same base. So you have negative x equal to 4. And solve for x. The rest of question are same thing. Or this question if you say, okay, can I use method 2? If I use method 2, then you simply put the e here. Right? You put the e here, and then you can, ln means log base e, so you can cancel out. So that's how you have this one. So this is by definition. If you directly go by definition, the input will be base e. Ln means base e, and the exponent is negative 3. So you can see that either method is okay. Let me clean up the work here so you can see the question better. Okay, here. Now let me rewrite the method 2 for you. So you have ln x equals to negative 3 for this question, and you may put the e on both sides. And when you put the e on both sides, you may cancel out these two. ln and the e, they are inverse function. You may always cancel out each other. So in the end, you have x equals to e to the negative 3. Now, I suppose keep going. Why I supposed to keep going? Because they ask you to round your answer to the decimal place. This part, you may do it by yourself. Number 5, I show my work here. You can just take a look. I always show my work by the first method, go by definition. Now, number 6. Number 6, you have same base. If you have same base, then the, let me make a better work here. Okay. When you have same base, you simply make sure your denominator equal to each other, and then solve for x. Number 7, you need to take away 9 first. Make sure one side is just the exponent. Then you go by definition. The exponent, this is exponent. Exponent equals to the log function. This is base. And this just the input. Now, when you have base not equals to 10, not equals to e, you need to use change bases. You change base to either e or base 10. So we use change bases. This formula. You can change it to any base. We learned that from last section. You can review this formula. And then use calculator. Number 8. Same thing, I try to go by definition. Now the exponent is the whole thing. And the base is 2. So I recopy this question here. Why? Because the original equation looks very confusing. Because their degree, their exponent looks almost the same size of the base, which is not good. I would like to have my exponent is very small, float in the air, so we can tell the difference. Which one is base? Now, you can put the log base 2, but when you have base 2, you cannot use calculator to find the decimal solution. So in this case, there's another way is you directly you put the ln on both sides. So this go by the method 2. You put the ln on both sides. If you put the ln on both sides, then you bring this exponent to the front, become the coefficient. And then you want to stand out x. Before you stand out x, you want to stand out -3 minus x. So all you have to do is you divide by ln2 on both sides. Okay, and then cancel out, right? Reduce the fraction. And then how you solve for -x? I did a little bit shortcut. So if you feel hard, you simply +3 on both sides. After you +3, you have -x equals to the 14. But we need to solve for part x. So you just put the negative. So you put the negative sign and the negative sign here. I just switch left hand side and this right hand side. So my left hand side goes to here. Okay. And the right hand side goes to there. I just switch the side. But if you do it by your own way, you won't make any mistake. Don't worry. You don't need to watch my work for every step, because when you learn up to this level, different students will have different steps. So you can choose your own way as long as it is the right way. If you have any question, you may show your work in the class time, and then I can find your mistake for you. That's the best way to learn. Number 9. So if you take a look, my work here, I simply change 2x to become second degree. So I have 1 degree here. Now, I can call this one is a square, right? My a square minus this. So in other words, you have a square minus 8 plus 12 equal to 0. So you factor, you are going to have a minus 2, a minus 2, a minus 6 equal to 0. So a equal to 2 or a equal to 6. We call this substitution method. Then after that, you still need to solve for x. So how to solve for x? Go by definition. You can solve for it. Now let me show you how to, if you don't want to go by definition to solve for your x, you may just put the ln on both sides. And then cancel out ln. So you have x equals to ln2. Same thing to this one. Number 10. Number 10. If you have 1 means numerator equals to denominator. So in other words, this numerator equals to this denominator. So numerator equals to denominator. That's equal to 1. Or you may do other method, which is, let me show you. 1 equals 1 over 1. Then we use cross multiply. Cross multiply. So 100 times 1 equals to the whole thing times 1. So these two are equal, and then you solve it. So the detailed calculation, I would like you to go through by yourself, and you can put the LN on both sides, and then cancel out. You can solve it. Next one, this one means base 10. Log, if you don't see any base, it means base 10. So go by definition, that's base method 1. You can easily solve for the answer. Number 12. First, you have to take away 4. Okay. And then you need to divide by 6. And then you put the E on both sides here. Okay. To cancel out. Then you have this one. Number 13. Okay, number 13, we start a more complicated calculation here. When you have two separate functions and joined by addition, subtraction. So addition means multiplication. When you combine these two ln together inside one function, then addition become multiplication. Follow our formula. If you don't remember the formula, you need to check last section. We have, if you have separate different log function joined by addition, then it's multiplication when you put them inside one single one. Single one. Okay. When you put them all together, addition become multiplication. Subtraction become division. Now, once you have just the one, then the question will be looks like the question ahead here. You put the E, you can put the E, you can put the E there. Okay, and cancel out this E. So you have this equals to this one. E to the first degree is still E. First degree, right? And then when you have a quadratic function, you use a formula to solve for the equation. That's not too hard. Number 14. See, when you have subtraction, you change it to, when you have subtraction here, you change it to division. And then some students, they probably try to move this one to the left-hand side, become subtraction. It's too complicated this way. When you have same log function, it means by, we say 1, 2, 1 property. You may simply cancel out on both sides. They have the same thing. So the input should be the same thing. Now when input you have the same thing, you may just do cross multiply. So this multiply this equals to this multiply that. It's a lot of work, right? Then multiply by FOIL. FOIL. Multiply by FOIL. Then you have this one, and then bring this plus x become negative x. Plus 9, minus 9 goes to the other side, become plus 9. And after you clean up, simplify, then you have a quadratic equation, and then you solve for x. Now, remember, when you solve for the logarithmic equation, you need to check the answer. Why you have to check the answer? Your answer need to be positive. No, not the answer need to be positive. Your input. Wait. Okay, let me rerun. Okay, so you have input x plus 8. You also have input x minus 9. And you also have input x plus 9. Now, because I already realized inside the root is negative. If inside the root is negative, square root of negative is not real. If not real, we don't even talk about positive or negative. You just say, no, you don't find any solution. If you find a real solution, then you really have to plug in to these three input, and then make sure after you input the x, they are all positive. So this one need to be positive. Okay. Number 15. So number 15, I may simply just use one-to-one property. So the input equal to input, right? Input equals to input. And simply I solve for the answer. The solution negative is okay, no problem. But you want to make sure when you input is positive. However, x minus 8, this number minus 8 is not positive. So we say no solution. Number 16, we follow the formula. When you have addition, you change it to multiplication. Again here, I think I have a shortcut. Let me write one more step. So follow the formula. Log base 4, and you have x, and become multiplication. If you bring these two together and copy, you just copy. Okay, so that's why I have, if I have one single log for both sides, then left hand side input equals to right hand side input. And then simplify, you can solve for it. Now when you have x equals to negative 6, what happens? X equals to negative 6 here is negative. So this one not a solution. Not a solution. Not a solution. But x equal to 4, you can double check. Okay, you check, and it's fine. Number 17, you have to divide by 9 first. Divide by 9. So you have this one, and then how you keep going, you put the ln on both sides, and then cancel out. So copy down the leftover, I reduce, divide by 3, so I have 4 over 3. So that's how I have the whole thing here. And then multiply. Negative 3 over 2. I multiply with the reciprocal. on both sides. So I have x equals to these two multiply. You can use calculator to find your answer. Number 18. Number 18, we simply put the ln on both sides and then cancel out e and the ln always are inverse function. You cancel out and copy the leftover. Copy whatever left over. Then you can solve for t. Number 19. Number 19. They didn't provide the formula, so I write down the formula. Now on the test, you need to memorize the formula. What's the formula? They didn't give you the formula, but actually they give you the name of the formula. They give you the name of the formula. So you need to memorize. So when they give you the name of the formula, it's kind of, they give you the formula. As soon as you memorize, compounded continuously, you have exponential growth or exponential decay, this formula. Now, depends on the interest rate is positive or negative. So the investment is the principal. Investment is the principal. Principal. And the rate, this is the rate. Rate R. Okay, so just follow the formula. Plug in your data. Now, how you use this data? This one important thing here is you have two questions. You double your amount or triple your amount. I don't suppose to say A. Double your principal. Sorry about it. If you double your principal. So double your principal means your income become double of your principal. So this 2p here, right? And the triple your principal. I didn't show work for part B. So this is A equal triple of the principal equals to the principal, and then follow the formula ERT. Okay. So basically the book, they give you a formula like that. If you triple, then you have 3 here, ln 3 for the formula. And your rate, you put your rate there. So same thing. I show my work to find the formula of the t. So the formula of t, if double, then you have 2 input to the ln function. Okay, this means double. And this is the rate. But I don't think you need to memorize the formula. So many formulas in the whole world. If you memorize today, I guarantee you don't remember next time. So I prefer you don't memorize the formula. You simply, I say you don't memorize too many formulas. But you do need to memorize this formula, right? You do need to memorize this compound continuous formula. But you don't need to memorize doubling time formula or triple formula. You don't need to memorize that, because double means you put your income double or your principal, and then you just cancel out. It's very easy. Cancel out. And then after cancel out, you put the LN on both sides. Not too hard. Okay? Cancel out. So you can easily calculate. And if you guarantee you memorize everything correctly, you go ahead to memorize because it shows on our textbook. Number 20. Number 20. Okay, so what's our first step here? Wow, very complicated. So that's what I did for this question. I realized we have common factor. At least the first common factor is that. So I pull out the common factor. So if I pull out the common factor first for e to the negative x here, then I copy down the leftover. I copy down the leftover. Negative x squared plus 5x and then equal to 0. So this is my first step. Okay. And then I take a look. I have more common factor. I find more common factor. So my step 2, I bring out the common factor x. So I have negative x plus 5. And don't forget, outside I still have e to the negative x. Now remember, we always want to put the x in front of e. This looks better. Okay. So that's how I have this one equal to 0. And keep going. So I skipped 2 steps. Now I show my work here. And then you have how many factors here? You have how many factors? 1, 2, 3. 3 factors. So either this one equal to 0 or this one equal to 0. Then where this one goes? E is greater than 0. Okay? Or we say E not equal to 0. If your base is not equal to 0, e to the negative 5 degree won't be 0, right? E to the any degree won't be 0. E to the any degree won't be 0. So this one will never be 0. Is not 0 for sure. If this part not equal to 0, the only possible you can multiply to equal to 0 is x equals 0 or x equals to 5. So you find 2 solutions. Now this is not a log function, not a logarithmic equation. This is exponential equation. You don't need to check answer. Sorry, I take back my word. You always, no matter what, you need to check your answer. Why? Because you may have calculating mistake. Now, if you make sure you calculate everything correctly, then for this type of exponential equation, if you can find out the answer, then you need to keep all the answers. You don't need to think about, oh, I will have an input. There's no input. You don't need to check the input is positive or negative. No such thing. Don't worry about that. Number 21, last question. They do provide a function for you. So this is a function they provide. And they say x between 3 and 30. I want to make sure did I check? Yes, between 3 and 30. Okay, that's good. Now also they give you n equals to 34. So n equals to 34. And what else they provide? So everything, Okay, now I think you are able to just solve it by yourself. My first step, divide by 2500, divide by 2500. Okay, and then copy down this part here. Just copy. And keep going. I put the log 10. Because this base 10, so I put log 10 on both sides. By this way, I may cancel out base. So this number will be here. This number goes to there. And then I divide by negative 0.12 on both sides. When I divide, I simply put on the denominator here, multiply. Then use your calculator. Then you are done. So thanks for watching the video, and I will see you next time. Bye bye.